Thank you, Mr. Tomar. Now I would invite Ms. Anuradha Vattem, lead architect, IIT Hyderabad, to present on 1M2M platform-based water monitoring case study. Ms. Anuradha Vattem is presently a lead architect of Smart City Research Center, IIT Hyderabad, and working on building a Smart City Living Lab, a live testbed for deploying, testing, and generating smart city solutions. She has over 25 years of rich industrial experience in design, development, implementation, analysis, and support of embedded systems and their applications in various domains like defense, space, industrial automation, and atomic energy. She's had a diverse set of experiences, worked in India and USA in industry and academia, and on systems that run underground to systems deployed in space. Ma'am, the floor is yours. Uh, Ma'am, would you be presenting your slides or?
Yeah, I would like to present my slides.
Okay, so
Can you give me this?
Request Asif to give the presenter rights to ma'am, please.
I'm giving the right, yeah.
Yeah, good afternoon, everybody. I thank you all for giving me an opportunity to present our activities at Smart City Research Center, IIT Hyderabad. So, I'm representing Smart City Research Center at IIT Hyderabad, and we are having a smart campus living lab. Means now, like everywhere, we hear of smart cities, and we thought we work with MIT, and we decided to have a living lab, first of a kind, where we try to deploy a lot of sensors within the campus. As everyone knows, campus is like a lot of place, people, energy, water, everything you can mimic a city, that you can mimic a city. So as of now, we are working on various verticals like power, energy. We have meters measuring the energy consumed, and even the solar energy. We have the meters installed, and air quality, water, weather, and crowd monitoring. These are the various verticals we are presently working on. And when we started working on this, then we worked with last CNRS and we got their 1M2M. So as all of you know, 1M2M is the IoT server, and it has a lot of interoperability and many other features which are really accommodative to get data from various kinds of nodes. As you look at this architecture, so you have lot of data coming in. When you see air quality, they're pumping data every 1 minute, and some water quality sensors they're pumping every 4 hours, and weather at every 1 minute. So we have data, different formats and different frequency with which the data is posted, and 1M2M helps in accommodating in all this data in different data containers. And we are taking all the data to 1M2M server. And as we all know, 1M2M is not a data warehouse. It is only a facilitator to get the data and then push on to a data warehouse. So we have implemented a data warehouse also. And in the data warehouse, we are storing whatever data comes in from the sensors. Apart from that, we started working with Indian Urban Data Exchange, that is like with IISc Bangalore, where they are trying to make common data models for throughout the cities of India. So we are working with them and making a standardized data models. As of now, 5 data sets have been published or generated by working with them. And so any user from anywhere, they can just get into the catalog of IUDX and get the data of IIIT. Though, as I say, it would be through proper authentication and valid users can only retrieve data. Apart from that, we thought the data we are putting in the data warehouse and it is available for application. How do we visualize? So in that, we have developed a dashboard and an app, and even we have the Alexa skills developed. Apart from that, we have done the smart home automation based on the sensor readings. So this is the basic information about the smart living lab which we are implementing in the Smart City Research Center. Now, in specific to the topic given for today, I'll be going in detail how we have implemented for water and what all things we covered and what all features of 1M, 2M were extensively used. So these are the various kind of deployment. When we are saying, like, we started with a ultrasonic water meter, and 1 second. These are the ultrasonic water meters deployed, and when we bought it, like, we were thinking they were expensive, around 45-50K. Then one of our engineers, we just were discussing, and we thought we should find a solution which can be a retrofit model. So this model shows a retrofit model, whatever like mechanical water meters which we have within our homes. Everywhere we see these mechanical water meters. We developed a solution so that it can take the readings and then transmit via Wi-Fi or wired network. And even we are trying to implement using the Wi-Sun network. So then again, there are like other water meters, like these two water meters, they try to measure the quantity, like what is the water flow, what is the pressure, and which really helps us, like whether we are having the enough pressure, or are there any pipe leakages, or do I need to tell the person to turn on the bore to get the tanks filled. All this information can be informed, like based on the data available from these sensors. So like when we are doing the water meters, like let us say I was discussing about the water flow meters, one thing we need to see is having sensors is one step or one milestone, but ensuring the data we are getting is valid data. So to calibrate, like we try to put in parallel, when you look at this network which we have deployed, we try to put different kinds of meters and try to calibrate against it, ensure that we are able to give the right information. In the course of this implementation, we have used various features of 1M, 2M, like access control policy, using generating the container, application resources, and even using the subscription, which was really helpful for us to do the archiving of data in the data warehouse. And we are also planning to use the flex containers so that we have the flexible definition of the containers. Based on the data we are getting, we can just program it accordingly. So this is the this is the live 1M, 2M distribution. Like we are trying to deploy. We have a proper semantic naming convention. So by seeing the name, we should be able to define like where the node is, what is the descriptor, what is the data we are getting. So one of the standard node descriptor for the water distribution, we are measuring pH, TDS, and water level, turbidity, all these parameters using these sensors. And about the water quantity, we are measuring these parameters like flow rate, pressure voltage, based on which we can make a decision whether there's a leakage or there is insufficient supply of water. All these things can be figured out from these parameters. And now, like, let us say I'm putting data, a lot of engineers are developing. Like, how do we ensure that one person is not disturbing the data generated by another vertical? So for that, we are using the access control policy, which is one of the good features of 1M, 2M, where we try to restrict, like for one user, there would be an admin user where he can write, read, or delete. And there would be a user like operator who can just only read. And there would be some engineers who are deploying nodes, they can only write. So all such permissions can be defined by writing the access control policy. For one of the cases, it is written admin, it is a 63, and guest, it is 34. And one more feature is subscription. Now, like I am filling the data, like let us say around 120 containers or 100 containers, the data is posted through various nodes. How do we transfer it to warehouse? Do I need to come in between and say, come on, transfer it? Or is there an automated way? And for that, subscription really helps. So this subscription feature, for every data container, we try to create a subscription feature. So this automatically goes into the table allotted in the data warehouse. So it is like we need not check or verify or do any manual intervention here. And this is one of the formats, like how to get data. As I said, when we if we are using a flexible container, then we should be able to define here. This is time, this is PM 2.5, this is temperature. I can write the way the container we would look for. And there is another feature, group based retrieval, where we try to, like, let us say I just want to know what all nodes water distribution has, and let me get the data all at once. Even that feature is available, so we are able to use that feature also extensively. And there are like discovery API, where we can say by label, like let us say IIITH or water distribution. Based on the label, I can get all the relevant data using Discovery API. So like building the API layer was also an effort made by our students. So it is like we have different kinds of API. We can just look for latest data, or a temporal API with some attribute filters. Like I can say, I need this node's data from day January 1st to February 1st, or I need only temperature data, I need water flow data. So this has a flexibility so that anyone can be able to use it the way they want and build the applications across it. And as we are an academic institution, we are more towards putting a model like of a smart city within the campus. So anyone can come and deploy their solutions and see how it works. And as I said, like we have been working with IUDX, right? And there, like we have defined the data model. When we say data model, here is a data sample which tries to tell you, like, these are the parameters and what is the data schema, what are the units, what is the accuracy, all these parameters come into the data model. And when I was mentioning about IUDX, there will be, like, to give a brief about it, they have a catalog where they try to say IIITH pollution data, IIITH water data. And some user, if some user wants to take the data, what he tries to do is he tries to ask for a permission. That is where a token is generated, and based on the token and after validating the token, the person would be able to retrieve data for certain amount of time. So that is how the data is being done. As today's topic is more on 1M, 2M, I thought I'll just go in detail what all features can be used and how useful this 1M, 2M is. And this is one like data model. I know it is not visible, but just wanted to show, like, this is the structure we try to use. Each data, each parameter, what all schema, the maximum, minimum, accuracy, all those parameters can be defined in the node descriptor. And based on the node descriptor, people will know what kind of data they'll be looking for and they'll be getting. And these are the, like, how IUDX will define, like, what are the APIs it supports. It has this individual API, latest API. Even it can send the version also. Now, like, when we are implementing these water nodes, what we found is there are like different kind of sensors. As I showed in my previous picture, there was a sensor which was a retrofit model, there was a sensor which was an ultrasonic model, and other one was sending data through GSM. So how do we accommodate all these nodes? How do we know, like, which data has come from which sensor, and for a particular type of sensor, what kind of data we'll be looking for? For that, we have incorporated a version information within the data so that each one can decide, like, based on the version information, what data they'll be getting. And all this is one milestone, as I said, like one effort. And now, like, we are putting a lot of nodes. As of now, in the campus, I can say we have 175 nodes deployed within the campus. It is like water, energy, air quality, and even crowd monitoring and solar. And also we are working with Silicon Labs on smart lampposts, and we are trying to put a Bison network throughout the campus so that everyone, any node near to that, can be connected. So, like, so many nodes are pumping. Then suddenly we realize, like, how do we ensure whether the data is being pumped regularly, Or are there any data outliers, like suddenly some node is pumping some irrelevant data? How do I monitor? So in that context, we have developed a framework where it tries to say like, what is the status, scan through the data, and depending on the frequency, how frequently it is posting data, is there a deviation? And if not, is there any outliers or any null data coming in? All these things will be decided by this framework. And this framework tries to use Telegram to send messages to us, like the user, administrator. We can define like, how do we want to send it? Like, is it user based, or like I want to send the whole summary, or I'm only interested in water nodes or air nodes? So all these configurability is incorporated in that, and this type of notification has been implemented too. And when we look about the analytics, so as I said, we have done with the dashboard, and we have made a dashboard where you can see on the map view which location, what is the value, what are the values, and I can go by location. When I click onto it, I can get the analytics like for a week, for a month, or for a day, how the variation is. So I need not go download the data and then try to plot. It is all available online. And we also have an option to save it as a JSON file or CSV, either of the files. And we also get a summary view where we try to see like for the last week how the things are varying. And when you look at this plot, like there are red things, right? The color wise, we know whether it crossed the maximum or whether it is in normal range. So it tries to accommodate all kind of users. There would be users who will be working on analysis, that is like engineers who want to really go in detail, and there will be users like professors who want to see what are the characteristics of the waveforms, how the data is variation, and there will be people like me who want to know whether nodes are functioning or are there any problems. So to cater to all these needs, our analysis tries to give different kinds of visualization. And as I said, we have done the Alexa interface, even the app interface, so that user can access the whole data if he has permissions without any issues. And once again, like because of we are academia institution, we are trying to see like understand the water consumption patterns. Like as I said, we were looking at the pattern. TDS value is raising. So why is it happening only in one RO tank? Why is it not okay? Then like we try to analyze when it was filled or when it was cleaned. So all these insights can be generated by collecting the data. So that part can be implemented, and even like water leakage, water quantity, we are trying to see from one point to the other point whether the pressure is maintained. What is the water flow? Accordingly, we try to see whether we need to inform the admin department to control or correct the problems. And in the course of this, our people engineers have done some publications and even filed patents for the retrofit model of analog meter. And as a part of Living Lab, we also conducted certain challenges. Like we had a water challenge, and one of our teams was a winner. And we had 3 winners across the country who did the POC within the campus. So one was like they're trying to say take the satellite picture and accordingly decide the leakages. The one was a retrofit, the other was a GSM based meters, and which doesn't need battery to be changed for a longer time. And we try to do more research on these activities. Like when we did the retrofit, we thought it's a simple battery based device. Then we are trying to reduce the cost. Now we are working on the solar energy, and then like we are trying to see whether we can integrate LoRa network into the module. So in academy, like the research, there is no end. Like we keep on continuing with the things. So that's all from me. Hope I am in time. Yeah.
Yes, ma'am. Thank you, ma'am. We would now